Ladies and gentlemen, please welcome Chief Executive Officer of Amazon Web Services, Andy Jassy.
Thank you, and welcome to the 5th AWS reInvent Conference. It is awesome to be here. It really is. It's our favorite week of the year. And 5 years ago when we started the conference, we weren't sure we could convince 4,000 people to come. And this year, we have 32,000 of your closest friends here with you, another 50,000 people listening on the live stream. And as I always say when we open this keynote, reInvent is a different type of technology conference. It's not intended to be a sales and marketing conference like most of them you see. It's really intended to be an education conference. And as such, we'll have over 400 breakout sessions available for you. More than half of them will be taught by customers or partners, so you get the unvarnished look at what's working for them with AWS, what things they'd like to see change. And then you'll have all kinds of other fun things. Congratulations to the News Cycle team, who last night won the first annual AWS reInvent Broomball Championship. You'll have a Tatanka buffalo wing eating contest tonight around 6 o'clock at Jassy. I encourage you to check it out. A pub crawl, the party tomorrow night. Lots of fun events. But I have a lot to get to in this talk, so I'm going to get rolling on it and giddy up. So I'll start with just a quick update on the AWS business. So in the last financial results that we released in Q3 of this year, AWS is a nearly $13 billion revenue run rate business growing at 55% year over year. We have millions of active customers, and we define an active customer as a non-Amazon entity that's used the platform in the last 30 days. And it's a very diverse and broad customer base, ranging from most of the tech startups using AWS and have been for a long time. These are companies like Airbnb and Pinterest and Slack and Domo and Robinhood and Intercom. And then every imaginable vertical business segment in the enterprise is using AWS in a meaningful way. In financial services, it's Capital One and Intuit and FINRA and the Commonwealth Bank of Australia. In healthcare, Johnson & Johnson and Merck and Pfizer and Bristol Myers Squibb. In oil and gas, Shell and BP and Hess. In manufacturing, GE and Philips and Schneider Electric. In technology, Netflix and Samsung and Adobe and Autodesk. Every imaginable vertical business segment in the enterprise is using AWS in a meaningful way. And you also see it in the public sector, where we have over 2,300 government agencies worldwide using AWS, over 7,000 academic institutions, and well over 20,000 nonprofits. It's a very broad and diverse customer base. From the very beginning of AWS, we always believed that our partner ecosystem would be very strategic to our business and to our customers. And that's because enterprises that are looking to move to the cloud are going to want to do so with systems integrators that they're used to using, and they're going to want to use the same software they've used for the last number of years just on top of AWS's technology infrastructure platform. And so as such, we have thousands of systems integrators worldwide who've built practices on top of AWS, and they range from not just the global SIs like Accenture and Cognizant and Capgemini and CSC and Deloitte and Infosys and Wipro, but also to the SIs who were born in the cloud or reborn in the cloud. And these are companies like SecondWatch and Bulletproof and Dataluz and CloudReach and Smartronix and InfoReliance, very broad group of SIs. And also thousands of ISVs who have either built their products all in from the get-go on top of AWS, like Acquia, or who have adapted their software to run on our technology infrastructure platform. And again, these are companies like Adobe and Atlassian and Autodesk and Esri and Infor and Informatica and Pegasystems and SAP. Very broad ecosystem. In Gartner's most recent Magic Quadrant for infrastructure as a service, you can see that AWS continued to maintain the strong leadership position it has. But interestingly, what they said was they estimated that AWS had several times the size of the next 14 providers combined. So it's a pretty significant market segment leadership position. And then this is an interesting slide. We looked at most of the billion-dollar-plus enterprise IT companies, and I think there's a couple things that you can take from the slide. The first is that there's a real changing of the guard happening right now. You can see that the old guard companies are either contracting or growing at anemic rates, and these are companies like Oracle and IBM and Microsoft, and a new guard at the same time are kind of rising to become the technology partners of the next couple decades for companies, and these are companies like Salesforce and Infor and Workday. The second thing you can see is that AWS continues to be the fastest growing billion-dollar-plus enterprise IT company, growing at 55% year over year. So reInvent is always a time for us where we do a little bit of reflection about where we think the cloud is. And I think there was a statement made by Fortune after our most recent earnings release that I thought was actually pretty apt in terms of where we are. And this report mused the following: AWS continues to grow at a nearly unbelievable rate, even as credible and very deep-pocketed competitors have emerged. That seems to indicate an almost insatiable demand from businesses that want to offload computing and storage tasks to third-party providers rather than build more data centers. And that's very consistent with what we've talked about the last few years at reInvent. A couple years ago, we shared that the cloud had really become the new normal, that companies of all sizes were deploying their new applications to the cloud by default, and existing companies were trying to move as many of their existing applications to the cloud as fast as possible. Then last year, we talked about the motivation for why the cloud is becoming the new normal, which is that it's so inspiring for builders to feel like they have control over their own destiny. That is very different from what had been the case for the last couple decades. And as we thought about it this year, we said, well, it's great that builders feel like they can control their own destiny, but what gives them the confidence to actually take action on it and to leverage it? And when we watched what builders were doing on top of AWS and we listened to what they told us they were able to do, what we realized was that the cloud and AWS made builders feel like they were equipped with superpowers. And it's kind of like the superheroes we used to watch as kids on TV, and I guess we now watch in movies, or James Bond or Ethan Hunt from Mission Impossible, the Tom Cruise character. When they were about to go out for a mission, they're handed these very crafty, helpful tools. The cloud and AWS gives builders capabilities that they never had before, not on premises, not anywhere else. And in their hands, these capabilities allow them to overcome any challenge they're trying to conquer and to be able to build and implement any new idea they could dream up. So if there are superpowers for builders, what are some of those superpowers? And I thought I would share a few of them with you today. The first superpower I'm going to talk about is supersonic speed. So if you look at how people end up moving to the cloud, almost always the conversation starter ends up being cost. Most companies like turning capital expense into variable expense. Most companies like having a lower variable expense in the cloud than they can do on their own, and they really like the elasticity both up and down as their demand fluctuates. However, almost always when you talk to companies, the number one reason they choose to move to the cloud is the agility and the speed that they get in the cloud. And when they talk about speed, it's two things. The first is the ability to spin up thousands of servers in minutes, as opposed to 10 to 18 weeks it takes for most on-premises companies to spin up servers. But even more importantly, what allows them to move fast is having a plethora of infrastructure services at their fingertips to get from idea to implementation in several orders of magnitude faster than they could before. And if you look at the AWS platform, we've built a very robust and fully featured technology infrastructure platform. We have over 70 services. We have a lot more services than you'll find anywhere else by a large amount. And I won't go through all the details of this. I'll just kind of quickly hit some of the high spots. We have these constructs called regions. It's a place in the world where we have multiple data centers that we call availability zones. It's a little bit different approach than some of the later coming cloud providers who will launch a region with just one data center. And it's part of why you don't see a lot of meaningful workloads being run in those regions, because companies who care about availability, and most do, want to make sure they architect their applications to work across multiple data centers. So we have regions all over the world. We have 38 availability zones. We have 68 points of presence for our content distribution network. Then we have a whole number of building block infrastructure services, lots of flavors of compute, object storage, block storage, file storage, archival and backup storage. We have a relational database service and a NoSQL database service. We have a content distribution network. We have all kinds of networking capabilities on top of these. We have app services like queuing and notifications and email and transcoding. Then we have a very large offering in the analytics space, in the IoT space, in the mobile space. We have hybrid capabilities that allow you to run on premises alongside of AWS, as well as migration services, a number of security and compliance capabilities. We have a people layer of services that we've added over the last few years that you've asked us to add more of, not just account managers, but support where we have a one-to-one technical account management relationship with you. We have professional services and training and certification. And then we have a marketplace that we've built over the last few years, which is growing unbelievably quickly. It has over 3,500 products in it from over 1,100 sellers. And just to give you an idea of scale, in the last month, over 300 million hours of this software is being run on EC2, and that's about 112% growth year over year. So a very fully featured, very robust technology infrastructure platform with a lot more capability than you'll find anywhere else. And we're also iterating at a faster clip than anybody. So just for perspective, we launched what we considered 280 significant services and features in 2013. That number was 516 in 2014, 722 last year. This year, we're ahead of last year's pace, and we believe we'll end up at close to 1,000 significant services and features. Think about that. As a builder on the AWS platform, every day you wake up, on average, with 3 new capabilities you can choose to use or not. So it's not just how many services and capabilities we have, but we're also iterating at a very fast clip by listening to what you tell us matters and then making that a reality. An example of a company that is making a huge shift to the cloud, in significant part because of the capabilities of the AWS platform, is the very large and venerable worldwide utility based in Italy, Enel. And to share their story and how they're moving to the cloud, it's my privilege to bring to the stage the head of infrastructure and technology services at Enel, Fabio Veronese.
Thank you, Andy, for inviting me here and for giving me the opportunity to talk about the first cloud revolution of history. It started here in the US and has been around for more than a century now. And now, no, it's not AWS. I'm referring to the electricity grid. Look, it is a service on demand. Just one click, and you have the light. And it is also pay as you go. If you switch it off, then you are only billed for your actual consumption. It has been growing ever since, and for such a long time that people working in the energy sector consider natural to think about energy as a proxy of the wealth of nation. The richer the nation, the higher its energy intensity. But then came the big crisis, which as well started here, and along with Lehman Brothers and many others, swept away this belief. Now, the world has changed. The old cause-effect correlation, which we used to know, are now gone. Now we live in the age of decoupling. Gross domestic products and energy demand are not related anymore. Neither are oil prices and oil demand, and nor oil prices and investment in renewable sources. And so, in all this turmoil, if the world has changed, Enel is bound to change as well. Enel features 89 gigawatt installed capacity, more than 40% of that coming from renewable sources. We have 1.9 million kilometer distribution line, and we are blessed to serve more than 61 million customers. Fortune magazine listed Enel as 5th out of 50 companies that can change the world. And yes, we still believe that energy is a crucial service to play a role in nowadays society. And about the less obvious concept of a smart utilities, let me leave you with this. 1 out of 4 digital meters installed in the world has something to do with Enel. And eventually, for those of you who are not accustomed to my accent yet, Enel was born in Italy, but now has a global footprint. I know that numbers are difficult to remember, so maybe rankings may make things easier. Comparing to the main European utilities, we are number 3 in conventional generation, but number 1 in renewables, number 1 in distribution extension, and in million customers. And thanks God, number 1 also in market capitalization, growing in a sector that lost almost 40% of its value in the last 6 years. So for all these reasons, and mainly for the last one, we look at digitalization as a necessity rather than an ambition. And necessity is the mother of invention. So we think that the second cloud revolution, which we are celebrating here today, is a wonderful opportunity for us to foster innovation and accelerate change in Enel. IT operations in Enel were bimodal. By bimodal, I mean almost neurotic, because we had a total outsourcing model serving Spain and South America, while Italy and East Europe were served by on-premises data center. And so our decision was clear and straightforward. Go to the cloud as fast as you can. That meant closing the more than 20 years lasting outsourcing contract and using our data center as a swap areas for our non-ready application. The complexity of the challenge came from the conjunction of 2 factors. The relevant volume involved, which you may see here, and an absolutely fixed time frame. That meant moving almost 25 servers per day, Monday to Friday, including Saturdays, Sundays, Christmas, New Year's Eve, Easter, whatever bank holiday you can think of. We involved many people in this project because with John Donne, no man is an island entire of itself. And I think that this applies also to companies. Accenture, in this transformation journey, supported us as main partner. And yes, you can imagine we completed the challenge, but I still wonder why. This slide is probably the main reason why I'm here today. We managed to get those savings, half of those savings right after the migration, but then playing with the services offered by AWS, we managed to get to those numbers. And so what? Yet another migration to cloud story? Yes, indeed. But this was massive and fast. And while massive is easily coupled with corporation, that is not always the case with fast. We were lucky enough to ignite a virtuous cycle between top management and IT team. My first and foremost goal was to convince 2 people in the company. One was my CEO, which is actually sitting there. How am I doing, Carlo, now at the moment? Well, thanks. And the second, our CEO, because moving to the cloud has to be a company decision, not an IT move. Having said all that, it was all about execution and tight monitoring. About the team, well, for once, having the operation people, the IT operation people, had the opportunity to lead the dance instead of following the latest developer trend. And I can assure you that this has been a fantastic motivation level. Also, the widespread concept of doing the right things, of being the good ones, so that nobody could complain, helped a lot. And eventually, we tolerated unfortunate technology choices sometimes, hazardous planning, and even poor service quality management. But one thing we did not tolerate at all was immobility. Having said that, what's next? In the near future, our idea is cloud normality, moving from cloud first to cloud only. And so getting rid of data center, of mainframes, and moving to 100% full cloud operating model. And as mature cloud users, we also want to go serverless, moving from server to services. IoT in Enel means enabling the rise of an ecosystem of energy management systems which will completely transform the utility business model in the next few years. And you know, an ecosystem needs a platform. And we elected AWS IoT as the enabling platform for IoT in Enel, because we needed a scalable, reliable, and integrated solution on which to build our new energy management system. And with this, I appreciate your time. It has been a privilege. Grazie. Ciao.
Thank you, Fabio. I thought you did great, by the way. And it is really a privilege for us to work with Enel. It's been very inspiring to see the commitment top to bottom in the organization. It's part of why they've moved so fast, and it's really neat how quickly they have moved so much to the cloud. Now, one of the primary reasons that Enel has moved to AWS is not just the breadth of services that we have, but also the number of features within those services. And it's one thing to have a set of services, it's another thing to have the depth within those services. And this is a slide that you've probably seen me present some variant of over the years. And what I often talk about is that lots of companies have a relational database service, but very few offer the selection that you have in AWS. So in AWS's relational database service, we have 6 engines. We have Postgres, MySQL, MariaDB, Oracle SQL Server, and then our own engine that we built, Amazon Aurora. You won't find more than 1/3 of those anywhere else. You see the same thing with encryption. Access control is a great example. In AWS, you can specify that Steve from the Seattle office can create a MySQL RDS database between 9 a.m. and 5 p.m., Monday through Friday, only in a virtual private cloud or a VPC, in the US East region, only on M4 XL instances, and can provision only up to a fixed amount of IOPS. Everywhere else, the only thing you can do is say Steve from Seattle can create any database from 9 a.m. to 5 p.m. Monday through Friday. That's a huge difference in capability. It's a huge difference in control. And these types of features and the depth within these services is really important to customers. Let me focus a little bit on one of these other ones, compute. So I'm going to start with our instance families. And I'm really only going to talk about instances today. We're going to leave containers and Lambda for tomorrow. And you can see that AWS has 9 instance families, ranging from our T2 family, which is our very low-cost burstable family. We have a general purpose family, our M4 family, which is a commensurate amount of CPU and memory. We have a dense storage family in D2. We have a memory optimized family in R3. We have a very large memory family that people are running all sorts of SAP workloads on called X1. We have an IOPS-intensive family in I2. We have a compute-intensive family in the C4s, and then we have 2 GPU families, one for graphics rendering in the G2s, and then one for general-purpose GPUs, or GPGPUs, in the P2 family, which are really good for HPC and deep learning workloads. And this, if you look at these 9 instances, nobody else has even half of these. And having this number of instances really matters for customers, because anybody that has any reasonable amount of workloads knows there's diversity in these workloads. They have different constraints. Some of those applications are compute constrained, or I/O constrained, or storage or memory constrained, or GPU constrained. And so I'll give you an example. Take our most recent instance family that we launched, the GPGPU family, the P2. People have been doing deep learning and machine learning on top of AWS in a pervasive way for a long time, and they were just using other instance families. Well, then we launched the P2 family, which is fantastic for deep learning. All of a sudden, it changes the speed and the cost with which people can get their work done. So this stuff really matters. Having this diversity really matters. We're constantly iterating and reinventing in our instance families. And so I thought I would give you a little bit of an update on where we are. Let's start on the left side with our T2 instances. So as I mentioned, T2 instances, lots of people are running these. These are our low-cost, burstable instances. They're really good for simple websites and for blogs and development environments. And we have a variety of sizes available, but we started getting feedback from some of our customers that they want to take advantage of the characteristics of the T2 family, but they needed larger memory footprints. Well, good news. Today, we launched 2 new instance sizes in our T2 family. The XL will have twice as much memory as the prior largest instance size in this family, which was the large, and the 2XL will have twice as much memory as the XL. How about our R3 family? This is our memory-intensive family, and this is great for workloads like high-performance databases, or distributed memory caches, or in-memory analytics, or genome assembly, or analytics, or SharePoint, or all kinds of other enterprise workloads. Well, I'm excited to tell you that available today is our new memory-optimized family, the R4. The R4s have twice as much memory in the high-end instances as the R3. They have twice as fast memory and faster throughput with the DDR4s. They have over 2 times larger L3 cache, which means that you have to go back to memory less often, which improves the performance of your applications. And then on the larger instance sizes, twice as many vCPUs. How about our I/O-intensive family? These are really useful, and we have a lot of usage of customers running NoSQL databases, Cassandra and MongoDB on top of them, scale-out transactional databases, data warehousing, Hadoop, cluster file systems. I'm excited to announce that coming in Q1 will be our new I family, the i3 family. The i3s will have over 9 times the amount of IOPS that the i2 family had, over twice as much storage with NVMe SSD drives. You'll see over 2 times the memory in these instances, and then again on the largest sizes, twice the number of vCPUs. How about our C family, our compute-intensive family? People run virtually any imaginable workload that needs compute on top of these, all kinds of web servers and batch processing and distributed analytics and ad serving and high-performance science and engineering applications. I'm excited to announce in Q1 that a new C family is coming, the C5 family. The C5 will feature the newest Intel processors, which are codenamed Skylake. They have all kinds of advanced capability, like the AVX512 advanced instructions, which make them very useful for compute-intensive workloads like scientific modeling and 3D rendering and cluster computing and machine learning inference and distributed analytics. They have 2 times the performance for floating point, transcoding and machine learning applications, up to 72 vCPUs, twice as large as the C4s. They have 144 gigabytes of memory, and our customers have repeatedly told us in the compute families that they also need a reasonable amount of memory, and then more than 3 times the throughput to EBS as the C4s. So 4 new instance families coming your way. How about GPU? Let's talk about GPU again. So we have these 2 families of GPU that we have all kinds of customers who are running GPU on top of us, GPU workloads on top of us. But what we've found and what customers have told us is that there are times when they need just a little bit of GPU, but they don't need all the GPU that you would get in a GPU instance. And GPU instances tend to be more expensive than some of the other instances that have other constraints. And so you can imagine you're running a workload, you need just a sliver of a GPU. You'd like to attach that GPU to your instance family. Or take a lot of gaming companies who need GPU for various reasons, rendering, but they also have games where they're compute intensive or they're storage intensive, and they actually just want to use some GPU with the C family, the R family, whatever family they're using. And so this was really interesting feedback for the team, and we thought about it. And we're excited to announce the preview today of a new service and capability called Elastic GPUs for EC2. And so Elastic GPUs will allow you to attach GPU to any of our 9 instances. And so very much like the way that you're able to mount EBS volumes for block storage to your instances, you will be able to do the exact same thing with GPUs on our instances. And it'll run the same OpenGL code that your application or game already runs and have it rendered on a GPU. And again, it's super useful if you need some amount of GPU, but you don't need the full GPU instances and you want to attach it to any one of your instances. So 4 new instance families, GPUs that you can now attach to all of your instances. Why stop there? We had a few other things for you in this space. Let's reevaluate the ends of these spectrums. Let's start on the left. So as I mentioned, loads and loads of customers are running T2 instances for all kinds of workloads, simple websites and blogs and dev environments and prototyping and server builds. But when you run a T2 instance, we also require customers in doing so to learn what an EC2 instance is, to know how to spin it up, to set up auto-scaling, to set up security groups, to learn how to use S3 and EBS. And we have lots and lots of customers who love having that visibility and love knowing that they can stitch together these components however they see fit. However, we also have a lot of customers who say to us, gosh, all I want to do is spin up a virtual private server or a VPS. Can't you just make that easy to do so that I don't have to know any of the details of any AWS services? So I'm excited to tell you about the launch today of a new service called Amazon Lightsail, which is our new VPS servers made easy. So this makes it incredibly easy to launch VPSs. It's really simple. It's just 3 steps, effectively. You choose whatever image you want, Linux, or Ubuntu. You decide which bundle you want, and there's 5 bundles from which you can choose. You pick a name for your instance, your VPS, and you hit create, and bingo, you have a VPS. And behind the scenes, we will spin up the EC2 instance. We will attach the SSD storage. We will set up all the permissions in identity and access management. We'll create the security groups for you. And then it's all created for you where you can hook up your DNS and IP address and you're ready to go. The other thing that's really nice about it, too, is if at some point you decide you want to learn more about AWS and you want to use more of the services, we've built Lightsail in such a way that you can effectively open the hood and use more and more of AWS. And then the packages here, we have 5 packages, but the baseline package starts at $5 a month, so very cost effective. How about the other side of the spectrum, on the right side? At Amazon, we think a lot about hardware acceleration. And I think there's a lot of people out there who are maniacal about the performance of their applications. And if you are, you'll do almost anything that you can afford to do to improve its performance. We're like that at Amazon. And yet, what I would tell you is if you look at the mission and the way that AWS has behaved from the very start of launching the business 10.5 years from now, we have always tried to take whatever we can use ourselves and make it exposable for you. We want every single company, even an individual in his or her own dorm room, to have the same access to the breadth of services, the scale of infrastructure and cost structure as you could achieve at the largest companies in the world. So as we've been thinking about hardware acceleration, we know there's a very small number of companies in the world who have the technical aptitude and resources to make this a reality, and we wanted you to have the ability to do hardware acceleration as well. So I'm excited to announce the preview of our new F1 instances, which are FPGA instances. So this F1 instances will let you know what they are. They have FPGAs attached to them. They allow you to build and write your own accelerations and then deploy them to F1 instances. So it'll allow you to develop, it gives you all the code you need and all the tools you need to develop, simulate, test, debug, and compile your code. And there's a hardware development kit available for you, as well as an FPGA image that we give you. You can create, either if you've built your own FPGA acceleration yourself, you can bring those to these F1 instances, or you can create one with our toolkits. You package those into an FPGA instance or an AFI, and then you upload it to an FPGA instance, and you're ready to go. We're announcing the preview today. In the coming weeks, when we make it generally available, if you're somebody who has built a number of these FPGA accelerations or want to build those, we will make them available in the AWS marketplace for others to be able to consume. So we're very excited about what this will allow you to do. So, 4 new instance families, the ability to attach GPU to any of our instance families, VPS is made simple, and FPGA instances at your disposal. I think it's fair to say we love ourselves some compute. And if you think about it, this type of breadth and this type of capability is incredibly important as a company when you're trying to move all of your workloads to the cloud or build any one you could dream up. Because you know that your workloads aren't vanilla. They're constrained by different pieces. And it is true that you could build a house, if you wanted to, with a hammer and a wrench and nails. It's possible. My guess is that house might not look great. I'm not sure I could ever get away with that. It's probably going to take you a very long time and be very annoying. And the same is true when you're doing product development. It is so much easier to build whatever you want to build if you have the right tools at your disposal. It makes it much faster, much higher quality, and much more cost-effective. And the reality is, what's true here in compute is true in every one of these building block areas in the infrastructure technology platform. You just find a lot more functionality and depth in those services in AWS than you'll find anywhere else. And it's one of the primary reasons that AWS continues to predominantly be chosen as the infrastructure platform partner for companies. It's also one of the primary reasons you can move at supersonic speed. The second superpower I'm going to talk about today is X-ray vision. X-ray vision is the unique ability to have visibility and vision. And I'm going to talk about 3 benefits of X-ray vision. The first is the ability to see through the hand waving and bombast. So, in the old days, because it was so hard and so expensive to be able to test and experiment for any period of time, you used to be able to get these old guard leaders who would stand up and make all kinds of wild claims or manipulate benchmarks to suit their own purposes, or take out full-page ads or billboards claiming whatever they claim, and you had no ability to know what was real. You'd have to make a buying decision before you could actually figure it out. Well, in the cloud, that's not the case. That ship has sailed, kind of like an America's Cup ship. And the reality is that any of these technology infrastructure providers will allow you to benchmark their services, do whatever you want with the benchmarks, test these services for any period of time so that you get to make an educated decision on what the best platform is for you. That's a very good world for customers, and we're very excited about that. The second benefit that you get from X-ray vision is the ability to understand your customers and business better through data analytics. It has never been easier and more cost-effective to collect, store, analyze, and share data than it is today with the cloud. And some of that has to do with the value proposition and the cost equation of the cloud. But a lot of it has to do with the services that AWS has made available to customers. We have a much broader analytics offering than you'll find anywhere else. You can do things like manage Hadoop, and manage Spark, and manage Presto, and manage Pig, and Hive, and Yarn on top of our EMR service. We have loads and loads of customers doing analytics on our Elasticsearch service. More and more companies now are doing real-time processing of streaming analytics on top of Kinesis, which is our service for processing real-time streaming analytics. We have a very large data warehouse service in Redshift that's growing unbelievably quickly. We have a BI service in QuickSight, which we just made generally available. And then we also have a machine learning service that we launched a couple years ago. And with this selection of services, and given the cost equation, you see lots and lots of companies who are running large-scale analytics. This is just a portion of those companies. And whether it's the very successful gaming company Supercell, which processes 45 billion in-game events per day to obtain key analytics, as well as to feed their real-time dashboards and applications, or Philips Health Suite, which is using AWS to securely capture and analyze and store well over 15 petabytes of patient data garnered from over 390 million imaging studies, medical records, and patient inputs. Or NTT Docomo, that's running their 10 petabyte data warehouse on top of Redshift. Loads of companies doing large-scale analytics on top of AWS. Now, I think it's fairly obvious that Redshift and EMR have made petabyte-scale analytics accessible to companies large and small. And if you think about it, with Redshift, customers can make complex queries on massive collections of structured data from all kinds of disparate sources with super fast performance. And for unstructured data, customers can use EMR in a fast and cost-effective way to process vast amounts of data in dynamically scalable clusters using popular frameworks, distributed frameworks like Spark and Hadoop and Presto. And yet, despite how powerful these services are, and they allow customers to really take on the largest analytics workloads they can imagine, there are a number of customers who say, look, I have simple analytics that I want to run, much more ad hoc analytics. And these are things like logs and raw event files, clickstream data. And what I want to do is I just want to query these things quickly and directly in S3. That was very useful feedback for the team, and we thought about, is there a third service and a companion to Redshift and EMR that would make sense for customers? So I'm excited to announce the general availability today of a new service called Amazon Athena. And Athena is an interactive query service that makes it easy to analyze data in S3 using standard SQL. It's really easy to use. You can query S3 directly. There's no need to move the data or load it into anything. You just query it directly at S3. There's no infrastructure to spin up or manage. There's no clusters to spin up or manage. The results and the response times are really fast, seconds, oftentimes milliseconds. And then you pay only for the queries that you actually run. So customers are really excited who we've told about this service, and we're excited to get it in your hands. Now, as we told some customers about Athena and the private beta, one of the questions we got, which is natural, is people said, well, wait a second, is Athena going to replace Redshift and EMR? And the reality is that each of these services are different, and each of them serve a very useful purpose. There are always going to be a lot of customers who have a need to spin up clusters and manage them and tune them. And these are customers who are running very large-scale analytics in a consistent fashion where the heightened performance is worth the effort in managing the clusters. Data warehousing workloads are a good example of that. When you're actually processing vast amounts of data from disparate sources, your financial database, your inventory database, your clickstream database, your retail database, and you need to take all that data and it needs to be stored consistently in a structured fashion. Data warehousing services like Redshift are optimized to run those queries super fast. If you look at standard data warehousing benchmarks, Redshift will run those 20 times faster than interactive query tools. That's because something like Redshift is optimized for that workload. Each of these services have a very useful place. In the same way I was talking about earlier, that when you're building a house, it's really useful to have the right tools for the job. The same is true in understanding your data. We're really excited for customers to get their hands on Athena and be able to use alongside EMR and Redshift. The third benefit of X-ray vision is the ability to see the meaning inside your data. So companies know they have a lot of data, and they try to do analytics on that data to better understand their customers and to better understand their business. But they also know that there's a lot of nuance in that data that's actually hard to detect. Predictive signals, sentiment, intelligence within the data, and it's difficult to know what's going on there without the right set of tools. And customers are anxious to be able to understand their data better. That's part of the promise of AI and machine learning, is to really make your applications more intelligent. And we have released a whole number of pieces here over the last couple of years that has led to a lot of customers doing this type of work in AWS. So I mentioned earlier the P2 instance family that's really optimized for deep learning. We have an unbelievable number of customers doing deep learning now on top of those instances. It's one of the fastest growing instances in our history. We released a deep learning AMI that's equipped with 6 of the frameworks that you can use to run various deep learning queries and models. About a week ago, Werner announced that we're making a pretty substantial investment in MXNet. I think you should expect us not just to be contributing to the community there, but also additional tools that will make it easier and easier for you to actually build your models and run them on top of MXNet. Now, those first 3 pieces are really aimed at deep learning and machine learning expert practitioners. And we will continue to provide tools that allow our customers who do machine learning and deep learning to do so on top of the platform. But we also are very focused on trying to make it easier for everyday developers who aren't machine learning experts to be able to do machine learning and get utility out of their data on top of the platform. And that's what we launched with Amazon Machine Learning a couple of years ago, which we're continuing to iterate on. And when we talk to customers, well, actually, it is part of why you see so much of this machine learning, deep learning on top of the platform. If just a few quick examples, and these are a smattering of some of those companies. If you look at Aon, which is the large insurance and capital advisory company, they run their financial simulations using machine learning algorithms on AWS and have reduced their simulations from taking 10 days to 10 minutes. Or you can look at fraud.net, which is actually a fraud detection platform. They've been using Amazon Machine Learning to build about 20 different machine learning models. They're saving $1 million a week now on top of AWS. Or you can look at Zillow as an example that runs their Z-Estimate service using machine learning on top of AWS. Lots of companies are doing machine learning, deep learning on top of AWS and have for a while. Now, when we talk to customers and we share with them how we're thinking about this space, what we found is that a lot of companies don't realize the heritage that Amazon has in the machine learning space. And part of that is just because we don't talk about it very much. It tends to be our style. But if you actually think about it, AWS has a very deep heritage in this space. We have thousands of people dedicated solely to AI in our business. One of the earliest features on the internet that people started using was customers who bought this item might also like these items. That was machine learning driven. If you look at the way we ask people in our fulfillment centers to pick items, those pick paths are all driven by deep learning and machine learning models. If you look at the X-ray features on our devices, and you think about when you hover over an actor on the screen, how it'll tell you who that is and what their background is, or you hover over a song and you get the lyrics, all driven by deep learning models. Look at what we've done with Echo and Alexa. That's some of the most interesting deep learning modeling around natural language understanding and speech recognition. We do a lot of AI at the company. And customers say, yeah, you're right. You should talk about that a little bit more. But you know what? What we'd really like is we'd like you to expose more of those services for us, so more of our developers can actually use those capabilities without having to try to figure out how to build these services themselves. And so that's what our intention is. We're going to launch a new set of AI services under the Amazon AI rubric. They're going to announce 3 of them today, and there'll be others coming next year. The first of them is called Amazon Recognition, which is an image recognition service. So recognition allows you to pass an image to us, either through an API or the SDK, and we will detect objects in an image. We'll be able to tell you that there's a person in this image, or it's a woman in this image, or it's a car, or it's a steering wheel. And it allows customers to build applications with advanced capabilities like, I want to do a search for women driving a car. It also allows you to know how many people are in the image, so that if you actually want to create thumbnail images of the people in there, you don't crop the faces out. We do facial recognition. So it allows you to tell what's happening with the face. What's the sentiment? Is the person smiling or frowning? Are there glasses on top of that the person is wearing? And then it also lets you do facial matching or face matching, so that you can say, do these 2 faces match, which is incredibly useful for applications in the security space. You can imagine unlocking your desktop based on facial recognition. And so the service is really easy to use. It will take millions and millions of images in batch form, or you can do it in real time. We have the ability, because we have so much data and we'll have so many customers using this service, to continually fine-tune these models. And because they live in the cloud, you get to enjoy those improvements for free and really under the covers. And then it's very cost effective. So that's the first service, recognition. The second service is called Amazon Polly, which is a text-to-speech deep learning service. So Polly allows you to take a stream of text and submit it to the service. This could be a stream like the temperature in WA is 75 degrees F. And Polly will then spin out an MP3 stream that will repeat what you actually put in the text stream. Now, there's intelligence inside of Polly such that when it comes out in audio, it doesn't come out the way I said it. It's very awkward to say things like WA, WA or F. It'll instead come out as the temperature in Washington is 75 degrees Fahrenheit. The service, again, you submit a text stream, you get back an MP3 audio stream. It allows you to cache the responses so you can use them repeatedly. The response times are very fast. It comes with 47 different voices in 27 different languages, fully managed service for you, and again, very cost effective. So image recognition in recognition, text-to-speech with Polly. The third service that we're going to announce right now is Amazon Lex, and it's what's inside Alexa. So Lex is a natural language understanding or automatic speech recognition powered by deep learning models. And it's the technology that we've built that fuels the Alexa platform and all the Echo-related devices. And so this will allow you to build all kinds of conversational applications. You'll submit either a piece of text or a piece of audio. You'll specify a response, and then it'll return that response. It's really interesting what you can do with the service. It gives you an integrated development console in AWS. You can set up whatever text or audio that you want to actually build conversational apps around. You can decide if you want to specify the responses. So for instance, somebody who delivers pizza may say, when somebody asks, I'd like to order a pizza, I want the answer to be what toppings you want. Or you can set up Lambda triggers or functions that goes out and gets data. So that same person can say, I want to order a pizza, and it can set up Lambda functions that send the response back being, OK, Andy, do you want your typical large pepperoni for $9.95? So it changes what you can do with these apps. You can build multi-step conversations. These are, again, these NLU and ASR algorithms and models. We have a lot of data that we're constantly going through that we'll continue to refine to make the models even better. It's set up with all kinds of enterprise connectors. So whether it's set up with connectors to Salesforce or Microsoft Dynamics or Marketo or Zendesk or QuickBooks or HubSpot. It's integrated with Facebook Messenger as well as Twilio. And then again, fully managed for you so you don't actually have to do any of the heavy lifting. So to share with you a demo on how this all comes together, it's my pleasure to bring to the stage the one and only, the inimitable Dr. Matt Wood.
Good morning, everybody, and thanks, Andy. So with Amazon AI, we're bringing the power of deep learning and advanced machine learning to all developers so that they can bake intelligence inside the heart of every application and inside the heart of every business. And with Amazon Lex, as Andy introduced, we're bringing the power of the platform, the engine that drives Alexa, in the form of automatic speech recognition and natural language understanding to all developers so that you can build conversational, intuitive, and efficient interfaces to your application and your business data. So what I'm going to do here is I'm going to run a demo, and we're going to try and book some travel using Amazon Lex. We're going to build a conversational interface which talks to the service. The audio from my microphone is going to go to the demo backstage, and then we're going to go and try and book some travel. And then after that, we'll take a look at the next level and talk about how it works. So, book a flight to London.
When do you want to travel?
Friday afternoon.
There is a flight leaving at 5 p.m. for $500. Book it?
Book it.
Okay, it's booked.
So that's a very simple example of the type of fluid conversations that you can have with services running on Amazon Lex. So let's take a quick look behind the covers and see how all of this operates. So the very first thing that happens is a recording of my voice gets taken and gets sent up to the Lex service. And there, the recording of the audio gets transcribed using automatic speech recognition, ASR, into text. And then we use powerful, deep learning-based natural language understanding to convert that text and understand the meaning and the intent behind that text. We do that in two ways. The first is we create a custom grammar graph. This allows developers to specify between 5 and 10 sample phrases of the type of questions that they want to be able to answer. And then the service takes those utterances and expands it automatically to over 50 different ways of saying the same thing. That means it's easy for developers to specify all the different ways that a specific question can be asked, and it also improves the quality of the interaction for the end user when they're asking the question. The second thing that we do is we overlay on top of that a knowledge graph. The knowledge graph contains core concepts, such as locations and dates and airports. And we can use that to add semantic information on top of the text that's coming from the automatic speech recognition. So here we know that it's not just a flight to London, but we can look at that London. We understand that we're talking about an airport, and we know that that airport is London Heathrow. So after that, we're able to take this information and we're able to map it to an intent. This is what the user, the end user, is trying to get done. And in this case, we're going to go and try and book some travel. And every intent is comprised of a collection of slots of information that we need to be able to go off and fulfill that intent. So the date of travel, the departure time, the origin and the destination, all those sorts of things. And what the service will do is it will start to map the information that's coming through, that's been detected through ASR and NLU, and map them into these slots. So here you can see we've seen that London gets mapped to the destination, London Heathrow. And after that, the service will guide the user intelligently to be able to fill in the rest of the information that we need to go out and fill these slots to fulfill the intent. So the next step is to be able to take this information and build out the response. So we could ask for clarification with the destination.
When do you want to travel?
So that gets sent back to the user, gets converted into lifelike voice with Polly, sent back to the user, and then we wait for a response. And then the cycle just continues again. We take the same input, this time the response, Friday afternoon. We pass it through the automatic speech recognition. We put it through the grammar graph and the knowledge graph with a natural understanding. Here we know that we've got a date. We know the relevant date. And the service understands context. So you can see here that it still knows the intent that the user is trying to fulfill, and that allows you to build sophisticated multi-step conversational interfaces where you can continue to clarify and guide the user intuitively to what they want to go and fulfill. In addition to that, you can provide personalization and metadata automatically, so you don't have to query the user for information that you already know. So that may be an account number or a login. It also could be, if you have GPS on your mobile device, the location that you're departing from. So here we can use Las Vegas, because we know that we're here, and fulfill that final origin piece automatically. After that, we can issue a final confirmation.
There is a flight leaving at 5 p.m. for $500. Book it?
Seems like a good deal to me. We accept the confirmation, and then we process the intent either automatically, or we trigger the business logic to run inside a Lambda function. So you can take your existing Lambda functions and have them triggered through natural language understanding and ASR through Lex. And that's it, boom, the flight is booked. So let's take a look at another similar example. And this time we'll use text interfaces instead of voice. This is the sort of thing that you might do through Slack or Messenger. And here, let's say that I don't know where I want to travel to yet. So I could ask the service to try and help me to determine where I want to travel. So I could say, well, somewhere with forests and lakes. And the service will return some photos. They look okay, but maybe a city with some great architecture. And you can see here we've delivered images that the user can choose from, and then we could allow them to click that and then put them into the flow of booking the flight and the hotels after that. So let's take a look at how this works underneath the hood. So although each of these individual services, Polly and Lex and Recognition, can be used independently, pulling them together allows you to build some really novel, sophisticated, category-defining applications. So here we have a situation where we want to be able to map images to to help guide the user to where they want to fly to. And so we can take an individual image from the billions that are created every single day, pass that image into Recognition, and have Recognition tell us what is inside the photo. Not just the dimensions or the file type, but we can say that this is a forest and there is a lake in this with some degree of confidence. And you can do that in real time through just uploading the image to the service, or you can apply Recognition to all of the images, millions of them, stored inside buckets inside S3, and they'll be processed in batch. And from there, what we can do is we can take all this additional meaning by looking inside these photos, and we can build an index. So we can take all this data, all this metadata, and load it inside a relational database. And then when a new input comes in from a user into Lex, we can parse that using ASR with text recognition, apply our NLU, determine the keywords, and then we can pass those keywords to Lambda to actually go run the query against the new index of images that we have, and then we can return the images that the user wants to see and allow them to use that to spur their imagination for the next destination that they want to travel to. So these are the type of net new functionality that you can add to existing applications and the type of new category-defining applications that you can build with the Amazon AI services. And with that, I'll thank you very much and hand it back to Andy. Thanks a lot.
Thank you, Dr. Wood. Always a one-of-a-kind presentation. We appreciate that. We're very excited about the AI services we're bringing to you, and we're excited to see what you do with them. The third superpower I'm going to talk about is immortality. A few weeks ago, I was having a conversation with my 13-year-old son, and we were talking about how his generation, or maybe his kid's generation, may be the first to live forever, or at least for a lot longer than what people have lived the last number of years. And as we were having that conversation, we were kind of debating, do you think you have to be born a certain way with certain DNA and certain genetics to be able to live forever? Or do you believe with all the advances in science and biology that you'll be able to supplement living beings with the right inoculations and vaccinations and protections to allow you to live forever? Now, I don't know the answer to this, but I do think that this issue is very applicable to businesses. It is really hard, if you're a business, to persist for a long period of time. If you look at the first Fortune 500 from 1955, only 12% of those companies are still in the Fortune 500. And by the way, in some ways, it's easier to live forever once you have the right supplements than it is to live forever in business. Because in business, you have to worry about what your competitors do, changing market dynamics, changing technology. But if you want to have a chance to live forever in business, one thing that's clear to me, at least, is that you have to be able to take advantage of the evolving technology trends and changes. Because the one thing that's been constant the last 10 years, and that I believe will continue to be constant the next 20 or 30, is that technology is going to continue to change at a rapid pace. And you can see it with startups who've built incredible businesses already from a standing start and disrupted long-standing industries or invented new ones. I mean, look at what Airbnb is doing in the hotel accommodation space. Look at Dollar Shave Club. Look at how they disrupted a really long-standing dominant business in Gillette and but they were bought for $1 billion by Unilever. Or look at what Pinterest has done with visual search. They effectively invented that category. But look at Slack, and look at what Slack has done for teams all over the world. Now, apart from all of these companies being built and running on top of AWS, the other thing they share in common is every single one of them, from a standing start, were able to leverage the flexibility, the capability, the power, and the cost of the cloud to very compelling extents. And the same thing is happening in the SaaS space. Every single vertical business enterprise solution is being reinvented. And again, you can see it in lots of places. You can see it with what Acquia is doing in the CMS space. Look at Infor. Infor was really the first SaaS company to really commit all into the cloud. And as such, they have had disproportionate benefits as their business is booming and it's continuing to have more and more scope and market segment share across all kinds of business analytics. Look at Splunk. Look at how integral Splunk has been in being able to help you understand your logs better and your operational metrics better. Look at Twilio. Look at how many companies now incorporate Twilio as their telecom play. It's incredible. Now again, apart from the fact that all of these companies are run on top of AWS, you look at this group, you look at Salesforce, which recently announced that they're going to put their core CRM application on top of AWS, and a lot of times people say there's something missing here. So all these companies, all these leading SaaS providers run on top of AWS. Where's Workday? And now Workday has been running development and test on top of AWS for several years now. But I'm excited to announce the news to you right now that Workday has decided that AWS is going to become their preferred public cloud provider for production workloads. And to share with you why they made that decision and their journey to the cloud, it's my pleasure to introduce the co-founder and the CEO of Workday, Enel.
Thank you, Andy, and it's great to be here. Just sitting back in the back room and seeing all the new innovation from AWS is really amazing. So just a little bit about Workday. We were founded in 2005 by myself and Dave Duffield, who has been my longtime business partner and mentor. We were refugees from the Oracle PeopleSoft takeover, which was very hostile, so I quite enjoyed that reference to the bombastic leader of that company. From day one, we set out to build HR and financial applications in the cloud. Different than other companies who were started at that time, we focused on large companies. We focused on the global Fortune 2000. And 11 years later, we are still focused on that mission. Today, we have 1,350 and growing large enterprise customers using Workday, of which there are 120 are in the Fortune 500. And when I say using Workday, it's for their core system of record for all their people or all their accounting or both. So truly their ERP solution, and we're typically replacing an Oracle or SAP or PeopleSoft installation. We're a core values-driven company. The two founding principles of the company are taking care of your employees and taking care of your customers. Very proud of the fact that we're consistently rated one of the best companies to work for by Fortune Magazine and the Best Places to Work Institute. And our belief is that happy employees make for happy customers. And to that point, since we started measuring customer satisfaction, we've always been above 95%. Today we were at 97% customer satisfaction. In those 11 years, we've grown the business from scratch to what Wall Street thinks will be about a $1.5 or more billion-dollar business this year. And growing nicely. We actually have our earnings call tomorrow, so I have to be careful what I say. Let's take a minute and talk about our technology. Starting in 2005, we had the great opportunity to start truly with a clean sheet of paper and design using the most modern technologies. We took a page out of the consumer internet, really looking at them as our guiding force for how new applications should be built, the Amazons of the world, the Facebooks of the world, and designed a new set of HR and accounting applications leveraging consumer internet-style user interface, mobile when mobile came along, and a scale-out architecture which sits very well with where we're headed with Amazon. We embrace this concept of the power of one, where every customer is on exactly the same version, one line of code, one security model, one user model, one user interface. That might sound like a simple thing to do, but if you compare it to our competitors, SAP and Oracle, who we affectionately call Frankensauruses, which are a combination of Frankensoft and dinosaurs, they largely got to the cloud through consolidation. They bought many companies, and today they have a portfolio of products with different user interfaces, different security models, different SLAs, and they spend much of their time trying to tie all those things together. For us, with this power of one, we're able to move quickly, that one version, be agile, innovate rapidly, and when we go from one version to the next, we bring all of our customers with us. Back when we started the company in 2005, AWS was just getting going. So like most companies starting at that point, we built out our own data centers. We built out our own infrastructure. But as we looked forward to the next 10 years and thought about where the world is headed, and looked at all the amazing innovation coming from AWS, we made the decision that the best thing to do was really focus on building great applications, but leverage the really powerful and broad platform of AWS. And to talk about how we're going to do that, I'd like to invite my own European, David Clark, our Senior Vice President of Technology, who will talk about the partnership. David?
Good morning, everybody. I was expecting to be the token European on stage here this morning. So you can imagine my dismay when I was preceded not just by an Italian, but by a Brit. However, I am your token Irishman here, so good morning. So I'm delighted to announce, as Enel described, that Workday has selected Amazon as its preferred provider for public cloud customer workloads. This means that all of the Workday applications, HR, financials, analytics, and planning will be running on the Amazon cloud. We conducted a very detailed technical assessment of the available options. And, perhaps unsurprisingly, since I'm standing here this morning, we came to the clear conclusion that AWS was by far the best choice for us and for our customers. As Andy mentioned, we have been using AWS services for quite a long time. We started way back in 2008, and I distinctly remember our first bill for $34.31. It was on my personal credit card at the time. Since then, we've used well over 100 million hours of compute services from Amazon, so we've long since blown through my credit limit. But we've also satisfied ourselves that this is a highly reliable and scalable platform which can achieve what we need it to do. More importantly for us and for our enterprise customers, we have extreme sensitivity around security, around privacy, around integrity for these critical corporate workloads. And we're very satisfied that Amazon has deep and mature capabilities to enable us to provide those services to our customers. It is right for enterprise workloads, and that's why we've made this selection and embarked on this multi-year partnership with Amazon. Also, in the spirit of David Ricardo's doctrine of comparative advantage, this means that we can focus on what we do best, building great applications for our global customer base. It also means that we can offer more choices for our customers in terms of how and where they deploy. And in particular, we will now be able to offer choices for our customers who have particular sensitivity around data residency, where the data lives, where it's stored. We will be rolling out our services progressively on AWS starting in 2017 with Canada, which is a country quite near to America. From there, we'll be expanding worldwide to other regions, including the US and Europe. So we look forward to working with AWS to bring our customers on this journey and help them realize the benefits of the public cloud. Thank you for your time this morning, and I was going to leave you by saying goodbye in Irish, but I feel that that would probably strain even the capabilities of the new Lex engine that Andy just announced. So thank you and goodbye.
Thank you, Anil, and thank you, David. We're really excited about the partnership and continuing to extend what we've been doing together. So you saw that startups and SaaS providers are using the cloud to a very significant extent, either to build new businesses from scratch or continue to evolve their businesses. And I'd say, generally speaking, enterprises have really started figuring out this same thing themselves. Now, if your plan as an enterprise is to fight gravity and accept having limited capability and moving slower and being more costly than you could otherwise in the cloud, it's going to be hard to compete even in the medium term. And I think that one of the biggest mistakes a large company can make is to give up their ability to evolve and adapt quickly as new technology capabilities emerge. I think if you look at this slide, this encompasses, again, a small group of the total number of enterprises that are now figuring this out themselves and using AWS in the cloud to evolve their businesses. Whether you're talking about somebody like GE, which is moving 9,000 applications to AWS, or Qantas Airlines, which has built all kinds of really clever applications that people on board their planes, their flight attendants can use to manage the plane experience better. They also have built a new hotel booking business called Huru.com on top of AWS in about half the time it would have taken them to do so on-prem and about half the cost. You can look at Motorola, which has about 60% of the global public safety market that's reinventing themselves as a communications platform on top of AWS. Or look at Capital One, that's effectively reinventing their consumer banking platform on top of AWS. Enterprises are figuring out that they have to use and take advantage of the new technology changes and the vast capabilities the cloud offers if they want to persist and be competitive and live forever. I think a great example of this is a long-standing enterprise that's themselves reinventing their business on top of AWS. And to share with you their journey to the cloud, it's my pleasure to bring to the stage the CTO of McDonald's, Tom Gergetz.
So good morning. It's an exciting time to be at McDonald's. We have a vision to be a modern and progressive burger company. And we know our customers' expectations are changing. They're looking for us to be available 24/7, both inside of our restaurants and out. They're looking for personalized experiences. They're looking for recognition for their loyalty and even options for delivery. So to meet those expectations, we're investing significantly in technology. Today, I'd like to share our journey of where we've been and where we're going to assure that we fulfill that vision. Orchestrating change and transformation of a company the size of McDonald's from a traditional technology company to a digital innovator is very challenging. Integrating our world-class point-of-sale system in itself was one of those challenges. To give you a scale and perspective, our point-of-sale system runs on 200,000 registers and 300,000 devices across the globe in varying configurations. For us to provide an integrated customer experience for kiosk, mobile ordering, and offers requires seamless integration of that POS at the scale of McDonald's. That in itself was no small task. So as we started to build our digital platform, we looked inside for our experience. We started by looking at hosting characteristics. We went to Asia, where we have a $1 billion e-commerce delivery business in 23 countries running today. We analyzed the operational aspects, we took a close look at the architecture, and we recognized we were going to require public cloud for its near infinite capacity and capabilities for our success. We took a look at the software characteristics, and we looked outside. We found no single provider that had a multi-channel capability or model to provide the requirements we had to deliver our platform. Just to give you a perspective, 69 million customers a day, 36,000 restaurants, 6,000 menu items in each of those restaurants of varying availability and configuration that need to come together at one moment in time for a customer experience. We knew there was nothing out there, so we knew we needed to have something new, and we knew we needed to do it ourselves. So when we started to build the platform, we had a lot of requirements. Scalability, security, capacity. I like to call them the illities. We needed all the illities. So we formed a strategy and developed a plan, and we do what McDonald's does best. We leveraged our partners. We used existing partners where we had them, and where we had gaps and opportunities and needed new talent, we brought in new partners. For cloud, we found a partner in AWS. We knew they had the reliability and the capacity to support the needs of our digital platform. We also found the other partners we had worked very well with AWS, their ecosystem, and their platform. Now, transforming the organization from a traditional technology to a digital organization requires much more than technology. This is another area where we looked to leverage some help. We went to AWS as well and engaged their ProServe team for their cloud adoption framework. Cloud adoption framework focuses very much on organization, skills, and best practices. People, process, and technology. It looks at it very well. Outcome for us, we developed our own McDonald's Team Cloud. Team Cloud was responsible for taking that cloud adoption framework and working it through the organization to assure success. The ProServe team also helped us in other ways. They gave us some great access to some deep technical knowledge and resources to help us tune our platforms and our services. The savings techniques we garnered from that engagement was worth the price of the engagement alone. So I'd love to share a deep technical diagram with everybody in the audience today. As you know, I can't. What I can share with you is a services diagram that shows some of the services we used. We started with IaaS, and we utilized over 35 services. So if you look in the center, you'll see our e-commerce platform. We typically refer to that as ECP. Backend typically uses EC2, EBS, ELB, and Elasticache. EMR, S3, and Redshift are used for the big data and customer engagement pieces. Direct Connect, Route 53, and VPC are used for the networking aspects. We also leverage Device Farm and SES, and finally CloudWatch and IAM for access management and monitoring. So what I'd like to share is our great success in launching our platform in the US and Canada this year. We're now looking to pilot in UK and Australia, and looking to deliver the platform in China in first quarter of 2017 of next year. Cloud services were clearly very important to us. And looking back, we had great successes and great surprises. To give you a perspective on some of the targets from a performance perspective, we were targeting our ordering throughput at 350,000 transactions per hour concurrent. We achieved 500,000, 43% improvement. Our offers target was 600,000 per hour concurrent. We achieved over 1 million, 66% improvement. That equates to 31 million transactions per hour or 8,600 transactions per second. Impressive. We started with IaaS, and we quickly recognized the value of moving to platform services. For example, our use of Elasticache prevents us from having to manage our own Redis clusters. So what's next for us? We're going to evaluate more platform services, ECS, Aurora, Lambda, and SQS for agility and scale. We want deeper integration with the services. We want to improve our capabilities. We're hoping to achieve much faster response times, greater movement to microservices, and improved automation capabilities. So, parting thoughts from me. First, in a transformation and transition such as ours, focus on your organization as much as your technology. We all figure out the technology stuff. Having the right organization, the right skills, the right people, and the right focus on your customer and your outcomes is essential to success. Second, pull in the right partners and technology. It's sometimes not possible to do it yourself, and leveraging the skills from the outside has led to a great success for us. Third, leverage platform services when you can. We started with IaaS. Looking back, platform services would have been a better choice for us to start sooner. We have an exciting journey ahead of us. Technology will be a key driver for McDonald's for years to come. I really like to recommend that you stop in and visit our restaurants. I think you'll also see the blurring of the digital and the physical at the same time. If you haven't already, I'd like you to definitely use our app. And for the one person in the audience who hasn't downloaded the app, please do so today. I promise you, we give away free fries every single week. So I'd like to thank AWS for giving me the opportunity to tell our story today. And I'd like to thank each and every one of you for your time and attention. Have a great afternoon.
Thank you, Tom. When I was a kid, the biggest privilege my siblings and I got was on the weekends, we would get this alone time slot with my dad on Saturdays. And the big activity we did together was we'd go to McDonald's. It was so exciting. And I remember that when one of us misbehaved and got punished, the big punishment, the thing you didn't want to have happen, was that you couldn't go to McDonald's with Dad. So I have a lot of nostalgia for McDonald's, and it's really an honor for us to get to work with McDonald's as they are reinventing themselves and making sure that they can use the cloud to be successful over the next 50 years. The fourth superpower I'm going to talk about is flight. And what I really mean by flight is the ability to fly. And I think as kids, and maybe some of us now, have the yearning to have the freedom to be able to fly. And I think for builders, the same yearning for freedom exists. The freedom to build fast, the freedom to understand your data better, and the freedom to unshackle yourselves from customer-hostile database vendors. Over the last couple decades, the commercial database space has not been a pleasant one for builders. And it's because the commercial-grade database providers are very expensive, they're proprietary, they have a high amount of lock-in, they have punitive licensing terms, and then, oh, by the way, you occasionally get a mail that says, good news, you're being audited. This is something that builders don't like. And it's why enterprises have been moving as fast as they can as many of their databases to open source database engines like MySQL and MariaDB and Postgres. However, to try and get the same performance in those open source engines that you get in the commercial grade databases is hard. It's possible. We've done a lot of it at Amazon, but it takes a lot of tuning. And what customers asked us to do is if we would figure out a way to bridge that difference. And it's why we spent a few years building our own database engine, Amazon Aurora, which gives customers really the best of both worlds. It gives you the speed and availability of commercial-grade databases, but at the cost structure and customer-friendly licensing terms of the open-source editions. Aurora is fully MySQL compatible. It has up to 5 times better performance than the high-end MySQL implementations. It's at least as available and durable as the commercial-grade databases, but at 1/10 of the cost. It is the fastest growing service in the history of AWS, and we have an incredible number of companies that are building on top of Aurora. These are, again, a small grouping of these: Expedia, and Netflix, and Pearson, and Ticketmaster, and Ubisoft, and FanDuel, and very broad group of companies that are building on top of Aurora now. And last year at reInvent, we announced a database migration service, and then we opened it up at the beginning of this calendar year. And since we opened it up, over 14,000 databases have migrated. I think it's fair to say that there's a lot of pent-up demand to get away from the old world of databases and have the freedom and the flexibility that you get with services like Aurora. A company that is moving all into AWS, but also going through their own journey of migrating a lot of databases to AWS is FINRA. And it's my pleasure and privilege to bring to the stage to share their journey the SVP and CIO of FINRA, Steve Randich.
I got to tell you, it's a real pleasure being up here today, telling our story, which I think is a great story. 2.5 years ago, we started a migration of our most critical systems to AWS. It's our market surveillance platform. Our center of gravity is now in AWS for our organization. 90% of our total data volumes in AWS, and yes, we started with the crown jewels. We've had amazing benefits in this journey. It exceeded all the expectations that we had set out for us, and we learned a lot, and we transformed our IT culture in doing so. So we're FINRA, Financial Industry Regulatory Authority. We're a Wall Street regulator. Our mission is to protect investors by making sure that markets operate fairly and honestly and that there's no market manipulation occurring. How do we do this? We use advanced technology and we collect a massive amount of data from the industry. All the exchanges and all the financial services firms that do securities trading send us all the orders, quotes, and trades that occur every day. It's a massive amount of data in that it peaks at 75 billion records coming into FINRA each day. We process every day what Visa and MasterCard process over 6 months. And what we do is we stitch all this data together and look at it over days, weeks, and months. Now we're talking trillions of records, over 20 petabytes. And we run complex, sophisticated surveillance queries against that data to look for suspicious activity. That's what we do. Now, how did we start our journey to AWS? Well, there was a flash crash a few years ago, a very unpleasant event in the markets. And as a result of that, the Securities and Exchange Commission proposed a new regulatory mandate to better surveil the markets. For one thing, it was very difficult to diagnose what happened. You know, whether it was algorithms, trading algorithms going awry or whatever. So the new regulatory mandate actually is going to ask for even more data, a more comprehensive look at the market, if you can imagine. Much more data. Bloomberg, when they talk about it, says it's going to be the biggest database ever built. And so we looked at how we're going to build this thing. And we looked at our current platform, which, as you can imagine, data warehouse appliances, which worked reasonably well to get us to the point where we were. But then when we look at the real challenge forward with the amount of data that we needed to collect, we very quickly determined that we needed something different. And so that's when we began in 2013 looking at public cloud solution with open source big data. That's really where we wanted to take this thing. So we looked at all the cloud providers. We had big data experts. I had one of the most senior executives at the largest technology company telling us that this doesn't belong in the cloud. It's not going to work. So we basically, through a combination of proof of concepts and a lot of analysis with the best and brightest employees at FINRA looking at this, by the end of 2013, we came up with a proposal and a model supported by performance modeling and proof of concepts on what this thing could look like architecturally. And so we said, let's go do it. Let's go build it now. And that's why wait for the SEC to make the final decision and working with the industry on when this thing is going to launch. We could use this architecture for our current surveillance platform and database. For all the obvious reasons that we're here for today, to reduce the cost, to get rid of the proprietary infrastructure, and to leverage massive processing and storage scale on demand and at commodity costs. So that's what we did. So beginning in 2014, we began building this new system and started cutting over in mid-2014, and we completed the project in full this past July. Our approach, very unconventional. As a Wall Street regulator, we operate in an environment that is conservative. There's a need for control, very cautious, particularly around cybersecurity. We moved our most mission-critical, data-intensive systems first, very bold. We had 4 principles that defined our strategic approach. So the first one was self-sufficiency. We wanted to do this ourselves. Didn't want to rely on vendors. In fact, we had vendors, cloud brokers, coming in one after another, and we very quickly, within a few months, got to the point where our skills were more profound than those of most of the vendors that we were talking in the market. Next principle was public versus private cloud. A lot of talk about private cloud, particularly in the financial services industry. Again, that need for control. our view is, why own, manage, and support all that commodity hardware? Why not be mark to market with Moore's Law? And furthermore, we find that private cloud is often pushed by infrastructure people who want to stay within their comfort zone. And yes, they may be buyers of the cloud concept, but want to do it internally, again, for that control. Another principle was open source. We wanted to use open source database products like HBase and Hive. We had streams of proprietary database vendors coming in one after another telling it wouldn't scale, it wasn't mature, it won't work. They've all been wrong. We've proven them all wrong. And then the last key principle is that we weren't going to do a lift and shift. What we wanted to do instead was a ground-up rewrite of our applications in the cloud to take advantage of the cloud model. It's what we call cloud done right. DevOps automation and cybersecurity protections built in from the ground up. That's what we did. Now with AWS, we've got a great partnership with them. In the beginning, we looked at all the major cloud providers, and we continue to do so today. And we've determined over and over again that AWS is several years ahead of the closest competitor. And in fact, that gap is increasing, if you can imagine that. Our scope now expands a very wide breadth of AWS products. And it's allowed us to achieve the freedom from the proprietary database vendors that were warning us. In fact, in HBase, we're up to 2 trillion rows in HBase today, and we expect that number to grow phenomenally. So the expertise that we've built is very profound. We've got 7 FINRA experts who are going to be speaking here at this conference this week. So what's next for us? We want to move the balance of our applications to AWS. These are stragglers. Again, we got the center of gravity in AWS today, but we want to move the rest, and they're likely going to be rewrites and re-architects, again, to achieve that DevOps optimization and automation. We're going to close our data centers, as you would expect, and we look forward, as Andy just announced, to achieve true database freedom from Oracle with AWS Aurora. The project met our expectations. In many regards, it exceeded them, and we got some huge pleasant surprises out of this that we weren't expecting at all. First of those, which we saw immediately when we started putting this in production in mid-2014, is amazing performance improvements. On average, 400 times improvement to interactive queries. The investigative capacity of our surveillance teams has expanded dramatically. It's like being able to research something and only being able to do a few Google searches a day. It's impossible. Now we can do these things in seconds and sub-seconds. And we're able to absorb market peaks like the Brexit in June without even having any operational challenge whatsoever. In fact, in many cases, we hit peaks where we're using tens of thousands of nodes momentarily and then taking it all down in EMR and able to handle the volatile peaks that happen in the marketplace without generally even being aware of it until after it happens and we review the logs. Back in 2015, about a year and a half ago, we determined, as many of us have, that cybersecurity is better in the cloud than it is in privately managed data centers for a lot of good reasons that I won't get into. And that bucked a lot of conventional wisdom, which wasn't helped by tabloid headlines saying that, surprise, surprise, Hillary backed up her email in the cloud. Resiliency. This is a more recent observation on our part. Having been CIO of 2 stock exchanges, including NASDAQ, and having been the CIO of Citibank, a lot of time spent on resiliency and disaster recovery. Given that our data is replicated and processed ubiquitously and virtually across tens of data centers, the whole model about resiliency and disaster recovery is changed. And with the public cloud computing done right, the resiliency, you just can't compare it to what you would have in a private data centers. And the last thing I'll say is that we've been very loud in the press and at conferences about our cloud efforts and our success, and we've attracted a lot of attention. We have dozens of companies, big banks, other regulators, financial services firms, coming in to learn from us and our experience. And we've now taken this to the point where we've got commercial relationships with a number of firms to provide that assistance. So I'm really proud of my team in accomplishing this. It's just been an amazing effort. We did it ourselves with the partnership with AWS, and I'm happy, delighted to share that story with you today. Thank you.
Thank you, Steve. It is not a surprise to me that so many companies are looking to FINRA for advice on how to use AWS. I would say that FINRA is one of the very, very top practitioners of building on top of AWS, and we've gotten an incredible amount of useful feedback in our partnership with FINRA, and we really appreciate it. So you heard about the traction of Aurora, how many companies are using Aurora. FINRA is moving their databases to Aurora. We've launched over 20 features in Aurora in the little bit over a year that we've had the service out there. But what remains as the single top request for Aurora? And this is probably not going to surprise you, but the single biggest request is people say, can't you make it Postgres compatible? People like using it in MySQL compatibility, but there are tons of people that are using Postgres, and Postgres, of course, is more semantically close to Oracle, so it makes moving your databases away from those old guard commercial-grade database providers to Aurora easier. So I'm excited to announce the launch of Postgres for Aurora. So Aurora is now fully MySQL and Postgres compatible. It has at least as strong durability and availability as the commercial-grade databases, and again, just 1/10 of the cost. It's really simple if you actually want to be able to move from a RDS Postgres Community Edition to a Postgres Aurora. You simply take a snapshot, you move it to Aurora, and off you go. So I think people will be very excited about this. We're really excited to provide it. And giddy up. The last superpower I'm going to talk about today is the power of shape-shifting. And we think of shape-shifting as the ability to change your shape or change your form to suit whatever circumstances you're facing. And I think something that relates to that in the cloud is hybrid. And I think that one of the things that was probably the most misunderstood about AWS in the first few years of our business, I think this is better understood today, was people thought, as we were educating folks about the benefits of the cloud, that what we were saying was to use AWS, you either had to be all in on AWS and use nothing on premises, or you couldn't use it at all. And of course, that was not a binary decision that we believed companies needed to make or would make. We knew that there are a lot of companies, even though every month you see more and more companies deciding to go all in on the cloud. Matson, the shipping company, the latest, just a couple days ago, most enterprises are going to operate in hybrid mode for many years to come. And what they really want is they want a way to operate their on-premises infrastructure as seamlessly as possible with AWS. And it's why, over the last number of years, we have built a whole bunch of capabilities to make that hybrid mode easier to run. VPC, Virtual Private Cloud, which effectively allows you to cordon off a portion of our network, deploy resources into it. You can set up subnets with IP address that are only addressable through IP addresses you bring to bear or through the internet, and that connects back to your own data centers via VPN. So it really has become an extension of customers' own data center topographies, and virtually every enterprise using AWS uses VPC. We have Direct Connect, which is a private connection from your data centers to our regions. We have a storage gateway that allows you to store hot objects on premises and asynchronously be loading all the rest of that data to AWS. We have Identity Federation. We have all kinds of deployment tools that work both on premises and on the cloud the same way. So a broad number of tools that make it easier for you to operate in hybrid mode. And indeed, that's why you see the vast majority of significant hybrid cases out there, the cloud portion being run on top of AWS. And again, a small smattering of the examples, but let me give you a couple. If you look at Johnson & Johnson, they consider the combination of their on-premises data centers in AWS their borderless data center, and they've built tools like their XBot that scan both on-premises and AWS every 10 minutes for any kind of compliance aberrations. Or if you look at Comcast and you look at their very successful X1 interactive and entertainment platform, it's another application that was built in a hybrid fashion using both on-premises and AWS. And yet, what we've seen over the last several months, as more and more large mainstream enterprises are exploring substantial shifts to the cloud, they say, look, I know that you guys don't make us make a binary choice between all in AWS or all on-premise, but you are actually forcing us to make a binary choice. And that's because virtually every enterprise in the world is virtualized on VMware. And because to date, VMware and AWS have done nothing really to integrate how they work together, it means that we are forcing customers to make this binary choice of either continue to use the VMware software to manage their infrastructure footprint that they know and love and not really be able to use AWS very effectively in the public cloud very effectively, or move to AWS in the public cloud and have to leave behind the VMware software they're used to running. And customers didn't really like that choice, understandably. And they say, look, you guys can understand why we'd want to actually have one bit of software to run across all of our infrastructure environments. And indeed, we want to use software that we're used to already using, the teams know it, and importantly, we want to do so without having to buy more hardware. There are very few companies in the world that are looking to buy more hardware. Most companies are looking to either stay pat or to actually shrink the amount of hardware they have as they leverage the cloud. So this was really useful feedback. We thought about it a lot as a team. We thought about what we might be able to do. Then we started talking to our good friends at VMware. And together, we announced about 6 weeks ago a new offering, which is VMware Cloud and AWS, which allows customers to use the same software they're used to running to manage their on-premises infrastructure and be able to use that same software to manage their footprint in AWS. It is a unique offering that you won't see anywhere else. It's the only one that's going to be operated and managed by VMware. It's the only one where you can use VMware licenses to apply to. And it makes tons of sense if you think about it, because almost all the enterprises in the world are virtualized using VMware, and AWS continues to be the significant market segment leader in the public cloud. So we announced this a few weeks ago. It had a pretty overwhelming reaction. People are very excited about this. And to share a little bit more about what the reaction has been and what we're seeing, it's my pleasure to bring to the stage the CEO of VMware, Pat Gelsinger, for a conversation.
This is reInvent, right, Andy?
This is reInvent.
Okay, wanted to just make sure I was at the right place. Yeah.
It's funny seeing you here again.
Yeah,
on stage.
great.
Well, it's great to have you here, Pat, and we appreciate you being here. And since we did the announcement, we've talked to a number of customers, and they're pretty excited. I was kind of curious what you found the reaction to be like so far.
Yeah, the response has been overwhelming. And if you think about those hundreds of thousands of vCenter users, it's like a seamless extension to a globally available, almost infinitely scalable hardware resource. They're just excited. You think about the developer. This idea that they could be developing in the cloud and bringing that seamlessly back on-premise, or on-premise and seamlessly moving into a cloud environment, a lot of excitement. And for the CIO, to him it's been a strategic game changer, because they now can think about their cloud strategy in a much more comprehensive, holistic way. And as your slide shows, it's not an A or B choice, it's an A and B opportunity. So overall, enormously positive response from the market.
Yeah, we've seen the same thing. Share a little bit about some of the use cases and examples of what people are going to do with the offering.
Yeah, well, the customer responses, we've really seen, what we call our Lighthouse customer program that we're rolling out together. And obviously, you had a few of these brands at the announcement. Cisco and Western Digital were there talking about their plans. Amadeus is one I like. They're the largest ticketing and travel company in Europe. And for them, DR is the use case they want to attack immediately with the joint offering. And really, I'll say for any CIO in the audience, your capital budget for DR in the future should be zero, right? That should all be done in the cloud. We also have customers like Tom, who was just here at McDonald's, and they're a joint partner and excited about the opportunity. Another one is, the state and local market has responded very well. In the state of Louisiana, a couple of years ago, they formed the Office of Technology Services. What they said is, boy, these little IT shops for all of the different state agencies, we're going to bring all of those together into a single offering. A lot of VMware customers as part of that. They're using our converged infrastructure to really bring that on-premise cloud experience, their private cloud environment, but also wanting the scalability. They have what they call their service-first mentality that they're building on top of a lot of AWS services. So they're excited to bring those two worlds together. Another one is Liberty Mutual. And somewhere in the audience, James McGlennon, the CIO, you out there somewhere, James? Give us a wave. Yeah, James is here, and he's excited. They're a 100-year-old insurance company. Right? You think about that, one of the largest, oldest, most mature and trusted brands in insurance. Huge VMware customer. They love us, they use us all over, but they've also said we're cloud first and our objective in the future is cloud only. And being able to bring those two worlds together, James speaks with enthusiasm about his ability to scale into that cloud environment. So again, we're very excited about what we're hearing from customers like them. Maybe the last one, Merck. Clark from Merck, what a big global brand. In fact, they operate in every country of the world. Which I was blown away with. And in fact, they have physical presence in 70 countries around the world, 7x24 global company. And the global footprint of Amazon is very exciting to him. Big customer of ours. And if you think about a company like Merck, one of the most regulated industries, the security aspects, the trusted brands that he's building his infrastructure on, really excite him as well. So again, world-class brands excited about becoming part of this offering. These brands are standing up to become part of our Lighthouse program. Yeah, it's really exciting. How about, for both of us, a very strategic set of partners or systems integrators? What's their reaction been? Well, system integrators, and we have 4 of them today, in fact, that have signed up to be Lighthouse customers. And to me, this is pretty good. They're paying us to learn to use our platform. Ain't that cool, Andy? Right, we have, today we have Accenture, CSC, Capgemini, and Deloitte, who are part of the Lighthouse program, because they've been building practices on VMware, helping people transform their on-premise data center environment. They've also been building practices on AWS, right? And how can they help their customers take advantage of yours? And when we announced this, it was like they were just ripping it out of our hands. And we're quite excited for these first 4 partners, and we expect many others in the future. Yeah. So the last question I'm going to ask you is, you could have chosen to partner with lots of different providers, and share why you chose AWS. Well, of course, it's your charm and magnetic personality. But seriously, I think this audience and this show represents it as well as anything possibly could. Our customers have asked us to do this together, right? And as we look at the hundreds of thousands of VMware customers, the now 1 million+ users of Amazon, they brought us together, and they're excited about the capabilities that we could do to make the seamless hybrid cloud experience, and their ability to move across those environments, accelerate their journey to the cloud. You know, the world-class brands. I mean, you've built an incredible franchise that is growing rapidly. The innovation cycle at our core, we're an innovative, hardcore, brilliant, innovative things. And that matches the personality of Amazon as well. So in every aspect, we're seeing the customers, the market, this particular offering, but even more importantly, the roadmap of innovation that we can deliver to the greatest companies on earth to help them transform their infrastructure. We're excited.
And we are too. Well, as we said, we have a huge amount of respect for VMware, and I think the offering is something that customers have waited for a long time, and I think are understandably excited about. We can't wait to make it easier for companies to move workloads back and forth between on-premises and the cloud, and we look forward to the partnership.
Andy, great working with you. Thank you so much, and thank you to reInvent.
Thanks, Pat. So we're really excited about the partnership that we're building together. And as I said earlier, it's going to take many years as customers are transitioning, where customers are going to run in this hybrid mode where they have on-premises data centers alongside AWS. So if you look further out in the future, what really does constitute on-premises infrastructure? And the easy answer today is to say it's servers in data centers or in co-location facilities. That's what infrastructure has looked like for the last couple decades. But what's happening at an incredibly fast pace is that more and more companies are deploying these connected devices, IoT devices, all over their assets. At the workplace, in factories, in cars, in ships, in airplanes, in oil fields, in agricultural fields, in hospitals. Every place they have assets, they like having these connected devices that collect that data and give them the ability to analyze what's happening and make changes. The thing is, when you look at these devices, they tend to be relatively limited in their capabilities. There you have a very small amount of CPU and a very small amount of disk. And it's why the cloud is disproportionately important to these IoT devices. And it's also why you see so many IoT use cases being built on top of AWS. And the vast majority of the popular IoT cases are being built on top of AWS. You can look at Illumina that's doing their genome sequencing and analytics on top of AWS. You can look at Major League Baseball and the StatCast feature they've built on their telecasts being done on top of AWS. Philips with their smart lighting. Tata Motors with their fleet efficiency. You can look at Under Armour with their connected fitness app. You can look at John Deere as they have over 200,000 telematically enabled tractors that are collecting data about conditions and then doing analytics and figuring out the optimal place for farmers to plant seeds. Virtually every big IoT use case right now is being driven on top of AWS's platform. Now, if you think about the future of what your on-premises infrastructure looks like, it's not that hard to imagine when you flash 10 years forward that those IoT devices make up the majority of your on-premises footprint. That's because over the next 10 years, I think it's fairly straightforward that the number of servers that companies are going to manage is going to shrink. And you see that in all the financials. You see it in the hardware providers. You see it in companies like AWS. However, the number of IoT devices is going to proliferate at a really fast rate as people are anxious to have those data collection devices on all their assets. The thing is, while it's relatively easy to take advantage of the cloud to supplement the lack of CPU and disk capabilities of those devices, there are going to be times where you don't want to actually make the round trip to the cloud. You can imagine a device that has to perform a certain function that has very low latency, sub-millisecond latency latency, where it doesn't have the time to go back to the cloud. Or you can imagine assets that live in places that don't have internet connectivity, or where the bandwidth is really expensive. So you need those devices to be capable. And the reality is, most of these devices today, just the nature of the size of the devices, have pretty limited compute and storage capabilities. When you buy one of these devices, whatever is in the device when you get it, that's what you got. And if you actually want to evolve it in some fashion or give it more flexibility or find a way to have more flexible programming models, it's really hard. Unless you're an embedded device developer, for everyday developers, it's pretty tough to deal with the antiquated protocols and try and mess with those devices. And even harder if you want to do it without taking the device or the application down. And so what we have heard repeatedly now from both companies that are using AWS's IoT offering and device manufacturers is what they really want is they want the ability on these devices to have the same flexibility and same programming model to do compute and to do analytics as they have in AWS. That was a really interesting insight for us as we heard it repeatedly. The team went away and thought about what we might be able to do about that. And we're excited to announce a new service called AWS Greengrass, which embeds Lambda compute and other AWS services in connected devices. So this is effectively a software capability that we'll embed in devices, and it allows you to have Lambda inside those devices, so you have more compute, and then you have flexibility in the compute and the triggers and the events that you can drive off of it. We have all kinds of encryption at every communication point, so it's highly secure. We have local data caching, so you can continue to store the state of the device for other applications to interact with. And then there's the local messaging component. What's interesting is device manufacturers and chip makers who make the chips inside of those devices will be able to build Greengrass inside it from the very get-go. Developers who have Greengrass-enabled devices where Greengrass is not in there will be able to download it if they want to. And then you can use a single console in AWS to set up a Lambda function. That function, you can deploy it to run in the cloud in AWS. You can deploy it to run on the device, or both. All the same programming model. It's very straightforward and simple. And then Greengrass has a really interesting additional communication capability where if you have a lot of devices that are clustered together, Greengrass allows you to set Lambda functions that can trigger other actions in those other devices so that the devices can communicate with one another, which is pretty neat. So, some examples. A lot of us now use smart home products where we use these IoT devices to control our lighting or our climate control. And in most cases, they communicate with a hub, and that hub connects back to AWS, where a lot of the brains and rules are driven and then sent back to those devices. However, as you can imagine, those IoT devices and the manufacturers of those want to make sure that if they don't have the right connectivity at any one point to AWS, the people can still turn off their lights or turn the heat on. And so they will build Greengrass inside of those smart hubs so that they can use AWS whenever they want and use Greengrass as a secondary in case the connectivity is interrupted in some fashion. Or taking agricultural provider. We have all of these companies now. I mentioned one of them earlier in John Deere. But what they want to do is they're constantly surveying on these cabs of these tractors or machinery the planting conditions or the weather conditions. And again, a lot of that data is being sent back to AWS to do very thoughtful and deep analysis on ways that farmers can be more productive. But there are times when they want that machinery to make adjustments or take actions on data that they're getting close to real time where they don't want to take the round trip back to the cloud. They'll embed Greengrass in those hubs and be able to take those actions quickly. Not surprisingly, a number of companies are pretty excited about this. The chip makers, Intel and Qualcomm and Annapurna, are all embedding Greengrass into their next IoT implementations. Canonical is making Ubuntu's distribution compatible, and they'll sell it also in Ubuntu Snap in their marketplace. You see Philips and JPL and Enel and Technicolor, who are all integrating with Greengrass as we speak. So we're really excited about what this will provide device manufacturers and developers who actually want to have a consistent, flexible programming model across these IoT devices and AWS. A year ago at reInvent, we launched Snowball. Snowball, for those who don't know, is a 50 terabyte appliance, hardware appliance, that allow customers to take data that they're storing on premises, load it into a Snowball in a highly secure fashion. We encrypt it 3 different ways, with a Kindle attached to the device so you make sure you don't make an addressing mistake and you can keep track of the progress of that ingestion, and then send it back to AWS where it's ingested in high-performance racks. We launched this last year. Before we launched it, we had lots of debates as a team about how many Snowballs we thought we needed. I remember I chastised the team a little bit that I thought we had ordered too many. Within a week of announcing Snowball here, we had to go back and order 10 times the number of Snowballs that we had. It's been incredibly popular. We can't believe how many Snowballs are out there and how much data has been moved from on-premises to AWS. And there are lots of companies, you can see a bunch of these here, who have used Snowballs to move significant amounts of data to AWS. And in fact, people have gotten so excited about Snowballs and have become rather attached to their Snowballs that they also enjoy sending us selfies with the Snowball. I didn't show some of the racier ones, but... And when we started talking to people about Snowball, and we weren't really trying to collect feedback on what the next version of Snowball should be. We were doing what we always do, which is talk to you guys about what's working and what would you like to see us add, because 90% of what we build is driven from what you tell us is important to you, and the other 10% we try to read between the lines and invent on your behalf. And the feedback we got on Snowball was really interesting. People were very excited about it, but they said, the next time you do something like this, what we'd really like is we'd like the Snowballs to be able to handle more storage capacity. We don't want to have to keep having 2 copies of the data as we're moving it to you, because as they were moving the data in Snowballs, they wouldn't get rid of the on-premises copy of the data until they were sure it was safely secured in AWS. That was really interesting. People said, when we're actually loading the data in Snowball, it would be really useful if we could actually be taking some of that data and synchronously be loading it up to S3. And then a number of people said, gosh, it would be pretty cool if there was some compute on Snowball. And so the team went away and thought about it. This was not necessarily the way that we were thinking about the next variant of Snowball, but there was clearly a lot of interest in these types of capabilities, and then put together the plan to launch the next variant of Snowball, which I'm excited to announce in general availability now, which is Snowball Edge. And so Snowball Edge is a new hybrid device with onboard storage and compute. And it has a lot of the same trappings that people have come to know and love about Snowballs. It has the nearly indestructible hard exterior. It's got encryption 3 different ways. In fact, the encryption is done on the device instead of the client, so the performance is even better. It has an e-ink device display, so again, you can make sure the addressing's right. You can make sure you keep abreast of your progress. But it has a number of capabilities that hasn't existed in Snowball. So first, it's about twice the size of what we launched last year. These are 100 terabytes, the containers of the appliances. It has a clustering capability so that you can, across multiple Snowball edges, you can shard your data. And so that means that you've got the right durability such that you don't have to keep a second copy of the data on premises. It has an S3 endpoint, so you can be synchronously loading data to S3, or you can take data from S3 in the cloud back into the Snowball Edge if you want. And then it has compute inside. This is really a purpose-built Greengrass device that has more storage and has more compute and some AWS endpoints, but it's got Lambda, and Greengrass inside. And to give you an idea of how much compute it has the equivalent of an M4 4XL EC2 instance of compute inside. So this is super interesting for customers. And let me give you some examples of how we believe it'll be used and people have intentions to use Snowball Edge. So think about Oregon State. They do a lot of research out in the ocean. It's oceanographic research. And the way they collect the data today are on these manual tapes. And then when they get back to land, they have to manually mount these tapes and store the data. Now, as you can imagine, it's very clunky. It takes a lot of time. It's highly error-prone. Instead, what they'll do is they'll use Snowball Edge. They'll be collecting that data as they get it on the ocean. They'll be doing some pre-processing and analytics on that data such that when they get back to land, they just attach that Snowball Edge into their data center network, load what they want, take the pre-processed data and make use of it, and then take the rest of it, disconnect it, and send the Snowball Edge back to AWS to do deeper analytics. The exact same thing is going to be done with airplanes who are collecting data constantly on flights where they want to actually know some of the things that are happening during the flight that might be useful to take action on sooner than later. They're going to have those Snowball Edges on board, be able to see some of those analytics, take action in real time, and then they're going to take those Snowball Edges when they fill up and send them back to AWS for more detailed and complicated analysis. Or take GE. So GE has these wind farms all over the world, and many of them are in remote places that have effectively no internet connectivity. And so there's all kinds of aberrations and signals in that data, and they're collecting massive amounts of data from these wind turbines that they want to actually be able to see in real time and set up analytics to understand those aberrations such that they can adjust or be more efficient in the process. They will use Snowball Edges to collect all that data, do quick analytics on things that they're seeing that can make them more productive and efficient, and then when they fill them up, they will disconnect them, send them back to AWS, and they'll do much more complicated and deep analysis on that. We're really excited about what Snowball Edge is going to provide customers, and our customers that we've shared Snowball Edges with are incredibly excited. It opens up all kinds of opportunities for them to have devices that they can have live with their assets, collect the data in a very highly scalable way, do analytics on that data, upload some of that data that they want to upload real time back and forth from the cloud, and then when they're done, disconnect it and send it back so that they can have that data for complete analytics in AWS. Very exciting. Now, a lot of customers are excited about moving petabytes and petabytes of data this way. A number of our customers said, well, this is great if I have hundreds of petabytes or dozens of petabytes. What about if I have exabytes of data? And we have a lot of customers who have exabytes of data. When we started AWS, the notion of an exabyte of data just seemed completely out there. Like an exabyte of data, it's so big. Today, an exabyte of data is a lot more commonplace. You'd be surprised how many companies, large enterprises and successful startups, given the way they collect data, have exabytes of data. They say, well, I love Snowball Edges, but if I have an exabyte of data, I'm going to need like 10,000 of those Snowball Edges. And that's probably too many for us to want to manage. So is there something you can do that allow us to move exabytes of data so we can leverage the cloud as well? So we thought about that, though, and that was a tricky one. And the first thing that came to mind was we're going to need a bigger box. Introducing AWS Snowmobile. So Snowmobile is a 100 petabyte container. It comes affixed to a 45-foot long container and truck. The way it works, we'll drive the truck up to your data center. We'll take the Snowmobile, affixed to the trailer. We have power and network fiber that will connect to your data center. You fill her up, and then the truck will come back, put the trailer back on the truck, and we'll move it back to AWS. If you think about the idea of moving an exabyte of data from on-premises anywhere, but especially the cloud, if you basically assign a 10 gigabit per second line to it, which is pretty reasonable, it would take you about 26 years to move an exabyte of data from on-premises to the cloud. Using 10 snowmobiles, it would take you a little less than 6 months. That's a pretty huge difference. And that makes, you would not believe how many companies now have exabytes of data that they want to move to the cloud because they want to take advantage of the storage services that we have, and they want to take advantage of the database services that we have, and they want to take advantage of the huge number of analytics services we have and the AI services we have. But moving exabytes of data before it was completely unreasonable and impossible. 26 years, less than 6 months with Snowmobile. Customers are going to be pretty excited about this one. So I'm going to conclude with just a few comments about the next 10 years. One of the questions that we get asked a lot, and it comes in the form of something like this, is they say, look, the first 10 years that AWS has been in the market has been just an explosion of innovation. Not just innovation from AWS, but innovation from customers of all sizes and what they've done on top of the platform. So does that mean the next 10 years is going to have a lot less invention than the first 10 years? And I really don't believe that's going to be the case. I believe the next 10 years will have markedly more innovation than the first 10 years. If you think about in the first 10 years how much time and energy and angst we wasted with people wondering, is anybody going to use the cloud? Will they use it for anything important? Will it be more than startups? Will enterprises use the cloud? Will governments use the cloud? Will anybody run mission-critical applications on top of the cloud? We spent a lot of time collectively wrestling with that question. Today, we don't have any if conversations. Every conversation is a when and how conversation. And a whole generation of builders are going to emerge that don't waste any energy on that. They will spend all of their time using the cloud and its massive capabilities to build new businesses that we never imagined before, and importantly, to take existing businesses and completely change the customer experience so they can persist forever. This is a world that I want to live in, and this is a world that I think is very exciting to everybody in this room. So I really hope that you take what you learned this week, you take it back to your companies, you figure out how to change your businesses and your customer experiences, and I really thank you for listening. Have a great conference.